All right. So inverse and joint variation, if you remember last year we talked about direct variation, right? If you don't remember, here's the direct variation, right? So direct variation simply means as one goes up, the other goes up, right? So we saw x get bigger, and that means that y got bigger. And then when we saw y get bigger, x got bigger as well, or smaller, depending on what the value was. Does anybody remember what the equation is for direct variation? Y equals kx. Perfect. Thank you to the both of you. So please have this written down if you don't remember. Direct variation is y equals kx, and does anybody remember what we called the k? Constant of variation. Okay? You guys and gals remember seeing this? Yes? All right. So in this section, you're going to need to know direct variation, joint variation, and inverse variation. All right? And so everybody good with the direct variation? Yeah? So let's run through an example of a problem that we did last year with direct variation. Okay, so the variables x and y vary directly. So that's really important. X and y vary directly. That means that we're using the y equals kx as our starting point, right? And then what's the first piece of information I give you? Right, so in order to write my equation, I need to know my k value. So I'm going to use the y and the x that they give me in order to find k. So all I do is substitute in. 21 equals k times 7. So how do I get k by itself? Divide by 7, and k is equal to 3. So that's the first part. But did I answer the question? Is that an equation that relates x and y? No. Who remembers? What do I do now? Plug it back in. So what do I actually write? Y equals 3x. This is worth 1 point. Right there. Right? Everybody good with that? Yes, no, maybe? Okay. And does everybody remember doing this? Right, where it was multiple parts? All right, whenever you deal with variation, you're going to have multiple steps. So you're going to solve to find your constant of variation, plug it back into the equation, and then use the equation. So it says, then find y when x equals -2. So what do you think I do? Just sub in the x value they give me and find the y associated with it. So what's y equal to? -6. So if you remember from last year, these are actually worth 3 points. Getting the right k value is worth a point. Writing the equation properly is worth a point. Using the equation properly is worth a point. Okay? So everybody good? Because your brain's going to want to take a shortcut. You're going to go, well, I found the k. I'm done. But there's still 2 pieces left. So inverse variation. Inverse variation means that as one goes up, the other goes down. So as x increases, y decreases. As x decreases, y increases. Everybody good with that? Okay, your general form is going to be y equals k over x. So direct variation, y equals kx. Inverse variation, y equals k over x. Everybody good? All right, and again, what's k stand for? Constant of variation. It's the same thing. It's just now it's going to be written as a fraction, which creates increase, decrease. So again, what is this going to look like in use? It's the same basic structure. Okay? What's the first sentence say? Right, they vary inversely. So again, that's the key, right? Whenever you see vary inversely, you know you're going to be using this equation, y equals k over x. And other than that, it's identical to what we just did. So what's the y value they gave me? 7. What's the x value? 4. Okay, and then I have to solve for k, right? So what's k equal to? 28. So there's 1 point, right? What do I do for the next piece? So y equals 28 over x. And then the last piece, plug in your x value, right? So there you go. Again, 3 points, right? 1, 2, 3. So it's a lot like what we've already done. And again, where do people lose points? Easy. You jump from here to here. Okay, I need to actually see the equation right now. Everybody good with that? Yes, no? Identifying variation types. So tell whether x and y show direct variation, inverse variation, or neither. So let's look here. So what is this? Is this direct variation, inverse variation, or neither type of variation? No, it's direct. Right. Now, does that look like what we normally write? Yeah, but we normally would put y on the left, right? So how you do this is you just want to isolate y, and then look at it. Does it look like a y equals kx, or does it look like a y equals k over x? If it's neither of those, then you just put neither, right? So what about here? Is this inverse, direct, or neither? Inverse. What do we have to isolate? Which variable do we have to isolate? Y. So get the y by itself. What do? Okay, divide by x. Does that look like inverse, direct, or neither? Inverse, right? Y equals the number over x. Everybody good with that? Yes, no? So what about y equals x minus 5? Have we had anything that looks like that? Is that inverse or direct? Or neither? It's neither because y is isolated, right? And it isn't direct, which is y equals a number times x, and it's not inverse because it's not y equals a number over x. Everybody okay with identifying based off of format? Yes, no, maybe. So again, this is neither. Okay, checking for inverse variation. So I want to know, does the following table represent inverse variation? Anybody have any ideas how to tell if a table is fitting inverse variation or not? Okay. So what's our equation for inverse variation? Okay. So the key here is the k, right? The constant of variation. It's got to be a number that is close to the same at every single step. Okay, it doesn't have to be perfect, but it needs to be close with our calculations. So the k should exist at every step in our table if this is inverse variation. So how do we get k by itself here? If I told you to isolate k. Okay, multiply both sides by x. So k is equal to y. All right, so now we're going to actually calculate these. So what's 58 times 448? So yeah, you guys might need a calculator. Let's go. What was it? 25,984. Okay, and then 62 times 424? 26,288. Okay. 66 times 392. 25,870 what? 2. Thank you. And then the last one, 70 times 376. 320. Okay. So if you take a look, those are the k values that this table is spitting out, right? Are they all close to each other? Are we all over the place, or are they really close to each other? They're close, and what number are they close to? Well, 25.9, right? 26.2. So they're right around 26,000, right? So if I were to write this as an equation, I would say that it should look something like that. Okay, as an approximation, is this exact? No, because the k isn't exact, but because every single step is very close, I can say, yeah, this is inverse variation. Everybody good with that? Yes, no, maybe? Okay. So are there any questions on how to determine if it's inverse variation based off of a table? So you actually just multiply your x and y's together, and you should get approximately the same number every step of the way. If you do, you put yes. If you don't, you put no. It should, if it's a table, it should tell you which type of variation it's looking for. Okay, because if it's direct variation, right, like on the sheet I gave you, right, then you take the y and divide it by x. And you should get the same k every step. So they should tell you which format they're looking for, whether it's direct or inverse. And you do not have to worry about pulling this with a joint variation because it's too complex. Okay, everybody good with that? Yes, no? All right, so they're going to ask you, write a model that gives C as a function of A. That's what I just wrote up. So you know it's going to be inverse variation. And what's our K value from the previous screen? What number were we close to at every step when we multiplied? 26,000. So that number that comes out of your multiplication is your k. Everybody all right with that? Yes, no, maybe? Okay. So now it says predict the number of chips per wafer when the area of a chip is 81 square millimeters. So is this an X or a Y? It's an X, right? So I'm just going to plug it in. 26,000 over 81, and what do I get as an answer? Please and thank you. 320.987. What's past 7? Okay, so that's a 7, right? 0.9877. And there you go. So based off of our chart, because everything was a whole number, right? I would round this up to 321. Okay, so if you put 321, you'd be all right. For me, just so you guys know this year, anytime we deal with decimals, I want you going out 4 decimal places. Okay, just like last year, right? Keep things as accurate as possible. That's going to become more and more important to us as we get into not trigonometry, but get into probability in the second semester. But is everybody okay with the basic idea behind this? How to find k from a table, how to determine if it's inverse variation from a table, and then how to use that equation. Everybody good? Yes? No? Maybe? I'll take a maybe. All right, so joint variation. This is where one quantity varies directly with the product of 2 or more. So here's your equation. Z equals A times X times Y. So you notice it's direct variation, which just means everything's being multiplied together, right? Why do I have Z marked there? Oh, okay. So as far as the language goes, this is actually really important. They're going to tell you in the directions, Z varies jointly with X and Y. And what that tells you is which pieces belong where. Okay, the first variable they give you is the one that goes on the left, right? They tell you it varies jointly, which is why we have the A. That's our constant of variation in this style. And then X and Y are the right-hand piece. Is everybody all right with that? Yes? No? So the language actually does matter. It tells you which variables go where. Okay, so the variables as they show up left to right is how they go into the equation left to right. All right? You good? Okay, sweet. Just making sure. And then A is our constant of variation this time, just like the K was before. All right. The variable Z varies jointly with X and Y. Again, that's important. So what kind of variation are we talking about here? Joint. So that means it's going to tell you it's a Z equals AXY, right? But which variables go where? Guys and gals. Which variables go where? Just in order, right? So the first variable you see goes on the left. You always have your A, and then the last 2 in order. Everybody good? All right, so and then this is just like everything else we've done. We need to find the A value. We need to find the constant. So what's the Z that I know? Right, equals A times X is 3, Y is negative 5. Uh, 75 divided by 15, that's what, 15, 30, 60, 4, 5, right? Everybody good? So any questions on how to find the constant? So just like everything else we've done, we're going to take that constant, write it back into the equation, and this is our equation. And then the last part says use the equation. So find Z when X equals 2 and Y equals 6. So what's 5 times 2 times 6? So Z equals 60 and you're done. So are there any questions on the joint variation? So the important thing here is that you just know the 3 formulas. They work exactly the same way each time. Okay, but you need to know direct variation, inverse variation, joint variation formulas, right? Y equals KX, Y equals K over X, Z equals AXY. Everybody good? Write an equation for the given relationship. So in this part of your homework, they're going to tell you what the variables are doing. You have to write the equation. So Y varies inversely with X. Okay, so we know what kind of variation are we going to have? Inverse, so it's Y equals K over X, right? Do I have any other variables in play here? No, I'm just inverse variation, right? So it's just Y equals K over X. Everybody good with that, right? Well, it should be pretty straightforward. Look at the second one. What kind of variation do I have? I have inverse variation, and I have direct variation. So I just work my way left to right. It says z varies directly with y. So what would that look like? What's direct variation look like? What's it normally look like? What's your general equation for direct? Y equals kx, right? But I don't have a y. What do I have? Z, and, oh, I guess I do have y. Sorry. So, but how would I change z varies directly with y as a statement? What does that look like? Well, what does direct variation look like? Not just y, but z equals ky. Is everybody right with where that came from, right? Because it's normally y equals kx, but we went z varies directly with y, so we get z equals ky. Is everybody good with that? All right, what's the next part say? And what? I hope you guys are paying attention enough to be able to do this on your homework, because it's always the section that throws people off. So are there any questions on the varies directly with y part? Okay, and inversely with x. So what does inverse variation look like? What's its general equation? Y equals k over x, right? Do I already have a k? So what do I have to add to get that second part? And that's your equation, y equals ky over x. Is everybody good with where this is built from? Any questions on what the word means? Or words mean? Okay. So, there's your homework. And that's the entire section. So, is this section heavy? Not really. It's a lot of just plugging into the formula, right? Work the formulas. And you've got the three: direct variation, inverse variation, joint variation.